Well, hello, it's Mauricio Bonifacino again. In this case, I'm going to present an introduction to the Cichorieae. I'm going to briefly mention something about the distribution and diversity of the tribe, comment on some of the defining features, offer some comments on the phylogenetic context, and then give some examples of main groups and important characters. The Cichorieae, they are such a well-defined group that they have been that this is the tribe that has been recognized since the very beginning of the times, more or less. Tournefort, we could say that it was the father of the Cichorieae. He assigned to this group that he called the Flos semiflosculos the number 13 in his classification system, but he defined them very precisely according to our modern standards. The name Cichorieae was proposed by students of Tournefort that we all know. It was Vaillant. And then it was Lamarck and Candolle who actually presented the name formally. The Cichorieae is also a tribe that is worldwide distributed, although it has more diversity in the northern hemisphere, with 3 centers of diversity: one in Southeast Asia, other in the Mediterranean basin, and another in Eastern North America. In terms of the diversity, according to a paper by Lack et al., according to the treatment of the Cichorieae by Lack in 2007 for the Kubitsky series, and based on the phylogeny by Killian et al., the Cichorieae is currently divided in 11 subtribes. And here we have how that subtribes are organized in terms of the different genera and the number of species that made up each of those genera. We see that the largest genera are Hieracium, Crepis, Scorzonera, Trogopogon, Pilosella, and Taraxacum. We are not including in this list and in this representation of the number of the species, with the size of the circle representing the number of the species, the apomictid or microspecies. Because just to give you an idea how crazy things can become if we take into account those microspecies, in the case of Hieracium, we could have almost 5,400 species, microspecies. And in the case of Taraxacum, we could go from 80 to 1,600 microspecies. In terms of the phylogenetic context, in the analysis of Funk et al. In the Funk et al. Volume from 2009, the Cichorieae was part of a group of tribes collectively known as the Cichorioideae that included the Vernonae, Mochini, Liabi, the Arctoctidi, Gorterini, Platycarpi, and Eremotamni. In a recent phylogeny by Mandel et al. From 2019, the Cichorieae was sort of kicked out of that group, and it's now in what will be its own subfamily. So the Cichorioideae, in the current sense, would only include the Cichorieae, which be sort of the sister clade to the Corimbi and the rest and the Asteroideae subfamily. If we look at the phylogeny of Killian et al. And we plot there the diversity, we see that by far the largest subtribe is the Hieracinae, followed by the Crepidini and then by the Scorzoneri. Uh, this tribe is known by some edible species. Perhaps the most known one is the lettuce, in this case with Lactuca sativa. But not only the leaves of plants are edible. The leaves of some Cichoriums and some Taraxacums are edible, in addition to the leaves of the Lactuca. But also the roots of some of the species are edible, like the roots of, for instance, Scorzonera that we could see in this image. And it's a case of where we could say that we have a universe of apomictic species, in this case illustrated by this field of Taraxacum. But so what are the defining features of the Cichorieae? The Cichorieae, it's, as I said before, it's a tribe that has, or a group of plants that has been recognized since the 18th century, since the beginning of the 18th century, and because it possesses a set of very easy to spot characteristics. For instance, these plants are in the vast majority herbaceous. They have latex present both in the above ground parts and the underground parts. We have latex in other Compositae, but only in the above ground parts, either in the stems or in leaves, but not in the underground parts as we do have in the Cichorieae. We have homogamous capitulus, like we see here in the case of Cichorieae, that are made up of florets with ligulate corollas. Notice the distinctiveness of the ligulate corolla. The ligulate corolla is a zygomorphic corolla with a well-developed limb that has 5 apical lobes. That is a true ligulate corolla. You need to be cautious when you look in the literature, because authors of old used to refer to whatever zygomorphic corolla with a very developed limb a ligule. But those are not true ligulate corollas. A true ligulate corolla is the one that we see here in the Cichorieae, in which the limb has 5 apical lobes. And that is the definite mark of the Cichorieae. Another trait is the presence of the vernonioid style. So the vernonioid style is also the style that we see in the Cichorieae, in which we have continuous stigmatic surface in the adaxial sides of the style branches, and the collecting trichomes are all over the style branches and extend far below the bifurcation point. That is the definition of vernonioid style, and that's what we have here in the Cichorieae. So the latex here you see in this section of a leaf of Taraxacum is present, stem, leaves, and also in roots, and that's the defining feature of the cardui of the Cichorieae. Sorry. Well, here we have an illustration of the main morphological characters in the Cichorieae. There you have the vernonioid style. Here you have the ligulate corolla. And here you have the calcareous anthers. The anthers have very conspicuous tails and are fertile. So the fertile part extends below the insertion point. Therefore, they are calcareous. And that is a distinctive feature of Cichorieae. So here is a close-up of Taraxacum, and there you could see the vernonioid style. Look, the very hairy shaft. That's so typical. And we can see the continuous stigmatic surface, but that's what occurs here as well. And here we have a very unusual member of the Cichorieae that used to be considered outside the tribe, and for good reason. That is the case of Gundelia. So, if you look at Gundelia, what you have here are one-flowered capitula, and look at the corollas. The corollas are actinomorphic. So no wonder it was not considered in the Cichorieae, but molecular data had proven that it belongs into the Cichorieae. It looks like almost like a thistle, but in fact it belongs into the Cichorieae. So those are in fact tubulose corollas. And here is another weirdo in the Cichorieae. This is a monotypic genus, and the only one in the subtribe Warionini. And here we have many flower capitula with tubulose corollas as well. A very, very rare thing in the Cichorieae. So one of the things with the Cichorieae, and I will say that is also the situation in the rest of the plant world, is that usually when a large group is easy to identify by this for the most part vegetative trait that I just mentioned, or a combination of vegetative traits and the shape of the corolla. Usually when you try to identify things inside a group, the situation is not so simple, and that's what happened in the Cichorieae. While it is easy to spot the tribe, once you are inside the tribe, to tell apart the groups is not very easy because there's no much variation in the morphological features. Pretty much all the Cichorieae have this sort of involucre, multiseriate involucre that we see here in Hypochyris. But in certain groups, you could have a uniseriate involucre, like we see here in Picrosia, for instance. And then there's the weird case of Helminthotheca in the Microceridini, in which we have 3 series of phyllaries. We have an outer series of phyllaries that's very conspicuous. Then we have an inner series of phyllaries, and then we have a tiny third series that is in between the two. And it's hardly seen there, but those are very small phyllaries that are alternating with the inner series. The cypsela in the Cichorieae are the must-have organ for genera and species identification. If you don't have cypsela, mature cypsela, you probably are out of luck for identification purposes. So it is important, and sometimes you need to have flowers and fruits in order to tell the plants apart. So important characters are the size of the cypsela, the shape, the pubescence, and the presence of ribs, and obviously the pappus, as the structure associated with the cypsela. In this particular case, we even see pallia present in the receptacle. The presence or absence of pallia is also an important character. So the shape of the achenes, the number of ribs of the achene, like we see in that Hieracium, or in this case in this Lactuca, in which is flattened. In Hieracium they are more or less terete. In Lactuca they are flattened, like in this case. Another important trait that we could identify in the cypsela is that elongated portion in the upper part of the fruit that is the beak or rostrum. The shape of that beak, the length, how thick it is, all those are important traits. The surface of the achene, like in this case of the Hypochyris, which is full of scales, that's also another interesting trait. And in certain cases, like the case of this Trogopogon in the Scorsoreni, it has the record in cypsela length, with cypselas almost 5.5 centimeters long without the pappus. Very, very remarkable structure. Now, speaking of pappus, the pappus is the most important feature in Cichorieae systematics. It could be either the presence or absence of pappus, the type of element, the heterogeneity in the floret and across florets in the same head. So in this case, now I'm going to show you the most important Pappus types in the Cichorieae from a work by Killian et al. From 2009. So the Pappus elements could be plumose bristles, like we see in this case of anisocoma on the left and Hypocheires on the right. Notice the what will be the body of the Pappus elements, and then how long the projections are. Very long, many times the thickness of the element. That would define a plumose bristle. Then we can have just scabbarded bristles. That's when the projections of the element are shorter than the thickness of the element. This is the case of the scabbarded bristles. And we could have also the palliaceous elements that we see in Rotmaleria and Catananche here. So these are the main characters that you will use to identify species in the Cichorieae. And if you want to, learn more about the Cichorieae, I suggest you visit this really cool site, cichorieae.taxonomy.net, which is the site that Norbert Killian, with a group of researchers in the Cichorieae, is maintaining, and it's a wealth of information on all things Cichorieae. And with that, I thank you for your attention.